High Performance Liquid Chromatography by MG Chem and MG School Education. Visit www.mygchem.blogspot.com. Follow us Facebook. Subscribe us on YouTube channel.
Principle of HPLC. High Performance Liquid Chromatography, HPLC, is basically a highly improved form of column liquid chromatography. Instead of a solvent being allowed to drip through a column under gravity, it is forced through under high pressures of up to 400 atmospheres. That makes it much faster. All chromatographic separations, including HPLC, operate under the same basic principle: separation of a sample into its constituent parts because of the difference in the relative affinities of different molecules for the mobile phase and the stationary phase used in the separation. Separation of components depends on relative affinity towards mobile phase and stationary phase. Here component A moves faster than component B. Because, component A, more affinity for the mobile phase. So component A is eluted earlier into the stream of mobile phase, but, component B, more affinity towards stationary phase. As it remains in the stationary phase. Apparatus of HPLC consists of solvent reservoir, pump, sample injector, column, detector, data collection devices, waste collector. Solvent reservoir. Mobile phase contents are contained in a glass reservoir. The mobile phase, or solvent, in HPLC is usually a mixture of polar and non-polar liquid components whose respective concentrations are varied depending on the composition of the sample. Pump. A pump aspirates the mobile phase from the solvent reservoir and forces it through the system's column and detector. Depending on a number of factors including column dimensions, particle size of the stationary phase, the flow rate and composition of the mobile phase, operating pressures of up to 42,000 kilopascals, about 6,000 pounds per square inch, can be generated. Sample injector. The injector can be a single injection or an automated injection system. An injector for an HPLC system should provide injection of the liquid sample within the range of 0.1 to 100 milliliters of volume with higher reproducibility and under high pressure, up to 4,000 pounds per square inch. Columns. Columns are usually made of polished stainless steel, are between 50 and 300 millimeters long and have an internal diameter of between 2 and 5 millimeters. They are commonly filled with a stationary phase with a particle size of 3 to 10 micrometers. Columns with internal diameters of less than 2 millimeters are often referred to as microbore columns. Ideally, the temperature of the mobile phase and the column should be kept constant during an analysis. Detector. The HPLC detector, located at the end of the column, detect the analytes as they elute from the chromatographic column. Commonly used detectors are UV spectroscopy, fluorescence, mass spectrometric and electrochemical detectors. Data collection devices. Signals from the detector may be collected on chart recorders or electronic integrators that vary in complexity and in their ability to process, store and reprocess chromatographic data. The computer integrates the response of the detector to each component and places it into a chromatograph that is easy to read and interpret. Detector. A chromatography detector is a device used in high-performance liquid chromatography to detect components of the mixture being eluted off the chromatography column. The detector senses the presence of the individual components as they leave the column. The detector converts a change in effluence into an electric signal that is recorded by data system. Ultraviolet, visible spectroscopic detectors. Measures the ability of solutes to absorb light at a particular wavelength in the ultraviolet or visible wavelength range. When light of a certain wavelength is directed at a flow cell, the substance inside the flow cell absorbs the light. As a result, the intensity of the light that leaves the flow cell is less than that of the light that enters it. An absorbance detector measures the extent to which the light intensity decreases, that is, the absorbance. 3 common types of UV visible absorbance detectors. Fixed wavelength detectors. Variable wavelength detectors. Photodiode array detectors. Fixed wavelength detector absorbance of only one given wavelength is monitored by the system at all times, usually 254 nanometers. Simplest and cheapest of the UV visible detectors. Limited in flexibility. Limited in types of compounds that can be monitored. Variable wavelength detector. A single wavelength is monitored at any given time, but any wavelength in a wide spectral range can be selected. Wavelengths vary from 190 to 900 nanometers. More expensive, requires more advanced optics. More versatile, used for a wider range of compounds. More sensitive due to photomultiplier tube-Bohr amplification circuitry. Fluorescence detector. Fluorescence detectors for HPLC are similar in design to the fluorimeters and spectrofluorimeters. The fluorescence detector is a near-ideal detector for those solutes that exhibit molecular fluorescence. Their sensitivity depends on the fluorescence properties of the components in the elute. Refractive index detector. Measures the overall ability of the mobile phase and its solutes to refract or bend light. Refractive index detector measures the molecule's ability to deflect light in a flowing mobile phase in a flow cell relative to a static mobile phase contained in a reference cell. The amount of defection is proportional to the concentration of the solute in the mobile phase. Applications. The information that can be obtained by HPLC includes resolution, identification and quantification of a compound. It also aids in chemical separation and purification. The other applications of HPLC include pharmaceutical applications. 1. To control drug stability. 2. Tablet dissolution study of pharmaceutical dosages form. 3. Pharmaceutical quality control. Environmental applications. 1. Detection of phenolic compounds in drinking water. 2. Biomonitoring of pollutants. Applications in forensics. 1. Quantification of drugs in biological samples. 2. Identification of steroids in blood, urine, etc. 3. Forensic analysis of textile dyes. 4. Determination of cocaine and other drugs of abuse in blood, urine, etc. Thank you. For more videos please follow us on MG Chem Facebook page and subscribe us on MG Chem YouTube channel.